ZEAL Education Society, redefining excellence.
Hello everyone, my name is TYEETesting. I'm a student of Electrical Engineering Department in third year in ZEAL Polytechnic. And today me and my teammates have made a project on testing of a rotor machine. These are the teammates. And this is a basic introduction of what exactly it is. Electrical maintenance programs are designed to increase the equipment promptness and uptime while decreasing capital and operating cost. Electric motor testing is usually the first thing to be sacrificed when cutting back on operational expenses. But smart companies understand that without proper maintenance programs, there is billions of dollars of lost revenue through increased motor repairs, downtime, and waste in industrial and commercial companies. Testing is important to check faults of the machine and to reduce the maintenance cost of the machine. So this is the content. First, we'll be learning about the importance of testing. Second, we'll be learning about the basic construction and working of an induction motor. Third will be the testing of induction motor, in which there is a routine test and other tests. In routine tests, there are insulation resistance test, high voltage test, no load test, and blocked rotor test. And the rest are the temperature test and overload test. The fourth will be the method of DC machine testing. The first will be the brake of DC machine. The second will be the swing burns test. The third will be the back-to-back test. And at the end, we'll be learning about the advantages and disadvantages of the DC machine testing. So the importance of testing is so we can check the quality, the performance, the efficiency, the errors, losses, and different faults in the machine. This also overall makes the maintenance cost less if we test it regularly. This is a basic construction and working of the induction motor. The electric motor construction can be done using rotor, bearings, stator, air gap, windings, commutator, etc. The rotor in the electric motor is the moving part, and the main function is this is to rotate the shaft of the generating the mechanical power. As you can see in the diagram, there is a wiring cover, motor frame, stator, fan blades, rotor, bearing, end well, two end wells, one at the front, one at the back. An electric motor is an electrical machine that converts electrical energy into mechanical energy, as we all know. Most electrical motors operate through interaction between the motor's magnetic field and electric current in the wire winding to generate force in the form of torque applied on the motor shaft. So in the second diagram, you can see how the three-phase input travels through the stator. Testing of three-phase induction motor. First is the routine test, as we discussed earlier, in which there is an insulation resistance test, a high voltage test, no load test, and a blocked rotor test. And the other tests comprise of temperature rise test and overload test. So first, getting into the routine test, which and in it the sub part is insulation resistance test. An insulation resistance test, that is IR, measures the total resistance between any 2 points separated by the electrical insulation. The test therefore determines how effective the dielectric, that is the insulation, is in the resisting the flow of electrical current. As you can see in the diagram, there is an insulation tester, and the tester is connected to the conductor, and the other is connected to the lead sheet. The second will be the high voltage test. High voltage test is usually performed to qualify the device to operate safely during rated electrical conditions, a way to check the effectiveness of its installation. The objective sought during the high voltage test will determine the type and amount of voltage applied and the acceptable current flow. You can observe the diagram. Third will be the no-load test. The no-load test of an induction motor is similar to the open circuit test of a transformer. The motor is not connected from its load and the rated voltage at the rated frequency is applied to the stator to run the motor without a load. The 2-watt meter method measures the input power of the system. As you can see in the diagram, the 3-phase supply at rated voltage and frequency motor, it's connected to two wattmeters, that is P1 and P2, and those wattmeters at the end are connected to a 3-phase induction motor, and there is no mechanical load on the induction motor. The fourth will be the blocked rotor test. The rotor is get blocked in the blocked rotor test. A blocked rotor test is normally performed on an induction motor to find out the leakage impedance. Apart from it, other parameters such as torque, motor, short circuit current at normal voltage, and many more could be found from this test. As you can observe in the figure, again there are 2 wattmeters connected. There is a reduced supply voltage given to the 3-phase induction motor. The other test comprises of, as we earlier discussed, the temperature rise test. The standard method of measuring temperature rise involves taking the difference between the cold and the hot ohmic resistance of the winding. This averages the temperature change of the whole winding, including the motor leads and end turns and wire deep inside the stator slots. This is a chart for your reference given below in the figure. An overload test. To run the test, perform the following steps. The steps are: first, turn the FLA dial back to its proper setting and let the motor run for at least 5 minutes. Open the contact or while the motor is running and start a timer. The overload should trip in around 3 seconds or within 10 seconds maximum. Here are a few advantages of testing of 3-phase induction motor. First, because of testing we can find the faults in the induction motor, obviously. Second, we can check the performance of the motor. Third, we can check the efficiency of it. And fourth, we can check the capacity of the motor. The methods of DC machine testing. The first is brake test. The second is wind burn test. And the third is back-to-back test. So the brake test, its direct method is suitable for DC machine. In direct method, the DC machine is subjected to rated load and the entire output power is wasted. The ratio of output power to input power gives the efficiency. It's the equation for efficiency of DC motor. For a DC generator, output power is wasted in the resistor. You can observe in the diagram it's given the motor output power is equal to torque into the angular speed. The torque being force into resistance multiplied by the angular speed. F1, F2 in the figure. F1 is equal to S1 into 9.8 and F2 is equal to S2 into 9.8. And here acceleration due to gravity is considered 8.9. The Swinburne test. The Swinburne test is indirect method of testing of DC machine. In this method, the losses are measured separately and the efficiency at any desired load is predetermined. Machines are tested for finding out losses, efficiency and temperature rise. For small machines, direct loading test is performed. As you can see in the figure, this is the Swinburne test, back-to-back test. Hopkins test is a useful method of testing the efficiency of the DC machine. It is a full load test and it requires two identical machines which are coupled to each other. As you can observe in the figure, two machines are coupled to each other. Is operated as a generator to supply. One of these is operated as a generator, in the figure it's labeled G, to supply the mechanical power to the motor, and the other is operated as a motor, as you can observe, M, it's noted M in the figure. For this process of back-to-back driving the motor and the generator, Hopkins test is also called back-to-back test or regenerative test. If there are no losses in the machine, then no external power supply would be needed. But due to the drop in the generator output voltage, we need an extra voltage source to supply the power input voltage to the motor. Hence, power drawn for the external supply is therefore used to overcome the internal losses of the motor generator set. Hopkins test is also called as regenerative test, as I said earlier, or back-to-back test or heat test. You can reference the figure for extra information. And these are the advantages and disadvantages of DC machine testing. The advantages is less power is required. And another advantage is, since constant losses are known, efficiency of the Swinburne test can be predetermined at any load. Disadvantages include iron loss is neglected. We cannot be sure about the satisfactory commutation on the loaded condition. We can't measure the temperature rise when the machine is loaded. And in DC series motor, the Swinburne test cannot be done. Thank you.
ZEAL Education Society, redefining excellence.